Hello Year 11 and welcome to our next video here on trigonometry. We're looking at trigonometric equations today. Now we've sort of looked at some trigonometric equations before this, but we're really looking at solving them now. Now the thing with trig equations is potentially we've got an infinite number of solutions. Now if I ask you to solve an equation like x squared equals 4, well, it's got two solutions. Could be 2 or -2. But if I say something like sine theta equals 0, well, we might know that sine equals 0 at 0 degrees, 180 degrees, 360, 540, 720, and so on. Right? We could even go backwards, say -180 and so on. Now, sometimes we just sort of write down some of the answers with an ellipsis, 3 dots at the end to show that it continues on like that in that pattern, but more typically, you're given some sort of domain, right, for the solutions. So you provide solutions within a specified domain. What's important with these is that you don't just find one solution, but you find all of them. Okay, it's possible there is only one, but you do have to be careful and thorough to make sure you get them all. Now, let's say cos x equals -1/2, and I want solutions where x is between 0 and 360 degrees. So a couple of things we need to look at. If cos x is negative, then I must be looking for an angle that's in the second or third quadrants. Okay, because that's where cos is negative. Cos is positive first and fourth. So my answer will be in the second and third quadrants. My answers. We know that the inverse cos of 1/2, right, that's our related acute angle, is 60. Right? Our related acute angle is going to be 60, because the cos of 60 is 1/2. So now I draw a little sketch here. Right? You can see here. You can probably hear some noise in the background. Sorry about that. Welcome to Talara. So here's my sketch. There's my related acute angle of 60 degrees in the second and third quadrants. Righto. So 60 above the 180 and 60 below the 180, my arrows there are probably pointing the opposite directions. So they're my two solutions, right, between 0 and 360, second quadrant, third quadrant, related acute angle of 60, right? So that ray represents 120 degrees, right? That's 180 minus 60, or 180 plus 60, 240 degrees. So those are my two solutions. You could always check that in your calculator, I suppose. You could go cos 120, oh, -0.5. Cos 240, there you go. But that's not going to tell you you've got all of them. Okay, so be careful and thorough. Here's another one, compound angles. So this is where it's not so simple as sine of x or cos of x or something like that. Or we make it a bit more complex. So sine of 2x or the tan of theta minus 60 or something like that, right? Now, there are different ways of going about doing this, but I certainly think the best way to do it is to use a substitution, right? Whatever that complex variable is, substitute a simple one. Right? I'll show you how that looks. Now, when you do that though, a couple of steps to go through. Use a substitution, adjust the domain, right? Adjust the domain, and then, right, make sure you do the substitution back at the end. Right, because the solution for the substitution isn't the solution to the question. This is what I mean. So the sine of 2x is √3 on 2. First of all, sine positive, so we must be in the first and second quadrants. I'm after solutions where x is between 0 and 360 degrees. Now, I don't want 2x, so I'm going to say let u equal 2x. Use a fairly common substitution. So in that case, right, if u equals 2x, let's adjust our domain for 2x, or for u for that matter. So I multiply each of these things by 2, and I get 0 times 2 is 0, 2x, and 720 degrees. Okay, so there's my new domain. That's the domain that I want to solve u for. So I'm looking for solutions for u between 0 and 720 degrees. Okay. Now, we already mentioned that our solution will be in the first and second quadrants. But keep in mind, it's not just between 0 and 360 anymore. So our rays will be in the first and second quadrants. The inverse sine of root 3 on 2 is 60, again. And here's my sketch. So my related acute angle is 60 in the first and second quadrants. Looks like this, produces these rays. And those rays can represent 60 degrees and 120 degrees, but they could also represent, right, 360 plus 60. Okay, so 60, 120, 420, and 480. Right, so that's all my solutions from 0 to 720. Okay, you can just sort of trace it around like a clock running backwards. From 0, I picked them up twice. Back around here, we've done 360. Then I picked them up another 2 times. Come around the second time, and there's my 720. So over the course of those 2 revolutions, I produced 4 solutions. Not terribly uncommon for people to write that as their answer and move on to the next question, but it's not correct. Right? I wasn't asked to solve for u, I was asked to solve for x. So, remembering that u equals 2x, that means that 2x equals 60, 124, 24, 80. Now if I divide everything by 2, that means that x is 30, 60, 210, and 240. Righto. So that's how we solve those. We substitute, right? We put a substitution in, a simple substitution for a more complicated variable. We adjust the domain. We find the quadrants according to the sign of our answer. We find the related acute angles in there, and then find what those rays represent over the domain, and then do the substitution again at the end. Be careful of the substitution at the end. Okay, 60, 120, 420, 480, you've done all the hard work. So often I've seen that written down as the answer, but it's not correct. Righto, that's it for trig equations. If you've got any questions, jot them down, let me know. Otherwise, see you in class.